My presentation will be about the chapter 4, that is on material for 3D printing. So I'm Claudiane Ouellet-Plamondon. I'm from École de Technologie Supérieure, Universite du Quebec in Montreal. And I'm also presenting this chapter on behalf of the co-authors, so everyone contributed to the chapters, and also there's more actually to be added, I think. Anyway, it will be a report from the committee. So this chapter that focuses on materials, so we'll first have an overview of the material requirement, and then we'll go into the material selection for extrusion, and then a quick discussion about matching, mixing, and pumping, and more then on the characterization test during the mix design process. So when we look at material selection, I think we have to think of everything that is involved. So we have starting materials, which are typically the same as for doing concrete, but we have more requirement in terms of the particle size and the chemical compatibility. And then we do a mix design process. So we will suggest some ratio for water binder, aggregate binder ratio. So you will see some in this presentation. And then there's the printing process. I think Reza showed us that there's many different platforms. So the mix design depends also on how you print it. And then the rheology, I think it's also, you need to consider it really at the material level. And then there's the ardent property, and then that is more influential for quality control and also for the structural design. So when looking at the materials, so I think it's the typical, so we have a binder and mixture and aggregate. So I think basically what is important here is we need also a mixture that will be there, because you need a material that is pumpable, that is fluid, but at the same time we want it to harden at a fixed, in a controlled manner to be able to deposit concrete on top of it. So when looking at the binder composition, I think the most frequent one is Portland cement, but we see also cement replacement. So then it's the typical ones. We start to see limestone powder, métal-colin, and other also, we can see also recycled materials. So I think that's a good place also to start to see, can we use recycled sand? We need small particles. So you can think of also material from other sources. When looking at the concrete extrusion, I think we also need to keep in mind what is the size of our nozzle. And then there's different shape available. You can have a rectangular one or a more spherical one. And then you think that there's one layer that is deposited, and the height of the first layer is related to the material property, the yield stress and the density. So we'll go over that. And then as we add layers, then the yield stress is also involved in how many layers we can add on and the maximum height. So when we look at the process, I mean, we start by, let's say, we mix the component together. So from time zero, from when it's being mixed, then there's the pumping and extrusion stage. And then there's the deposition of the layers. And then we have what we call the green strand. So it's when the material is still at the early age, more fluid, and then there's the rapid strain gain that is linked with the hydration process. So there's many admixture that can be used, and then they target different requirements. So if we want a very fluid mixture, we use a high range water reducer, and then they allow a better dispersion of our particles. If we want mixed stability, we use viscosity modifying and mixture, and then they affect also water retention. For the stage of the rapid structural buildup, during deposition, then there's different, and make sure you don't necessarily need to use all of them, but they have been shown to improve the stage. So again, the viscosity modifying and mixture, the nano clay as well can improve the flowability and the structural buildup. And we can have also the short polymeric fibers that they can have a shear thinning effect, and they can also help structuration. For the control open time during the green strand, then we need, well, the polycarboxylate ether high-range superplasticizer are suggested. So they do a hydration retardation. It's also possible to use sugar derivative, but then that will increase your open time because they usually are having a retarding effect. And then if you want to control the setting time, then there's many different type of admixture. So you can be using, additional clays, inorganic salt, additional PCE, CSH seeds that are, these, the small particles of CSH that can also have an accelerating effect. And you can use also short creek accelerator. They really fasten the setting time. And for the hardened concrete property, we have seen saturated lightweight aggregate that are having a reduction of the early water loss. And then we can have also shrinkage reducing admixture to reduce the plastic shrinkage. So that's a lot of different type of admixture. I think the idea is really to see, the combination that works better for your system. And for shrinkage reduction, fibers are one option to reduce the shrinkage and cracking. In terms of the aggregate needed, I think there's been a review that has been done on the maximum aggregate size. So I think it's good to also put the printable mortar in relation to other type of mortar and grouts and concrete and printable concrete. So I think more often we have the printable mortar. So you see that the maximum aggregate size is usually a maximum of 4.75 millimeter. But, we have seen if the system is designed for concrete, you can go for up to 12.5 millimeter aggregate, which is larger size. And then in the chapter, you will have time to look at, the sand to stone ratio, the stone to binder ratio, the sand to binder ratio. So we reviewed all of that. So I think it's give good indication for someone who wants to start their own mixtures. Now let's look at the batching, mixing, and pumping stage. So in terms of the batching operation, it really depends on your system. If you do a desktop printing system, then you need a small scale. If you do a larger scale robotic, it's a different size of operation. And if you do a large scale gantry system, for example, then you need to size everything accordingly. But I think the idea is try to not to change so much the practice. And then there's a direct link between the nozzle and the maximum aggregate size. So we've seen different requirement. I think one easy to remember is your maximum aggregate should be 1/4 of your minimum nozzle size, or the minimum pumping size in your line. So your aggregate needs to be 1/4. And in terms of pumping, we look at the recommendation from ACI Committee 304, and then they recommend 1/3 of the hose and 1/4 of the trimmy pipe. So these are also other good indications. Now, in terms of the characterization during the mixing process, I think the very important factor is the yield stress, and then we can test it before during the mix design process, and it's good to test it also in line and during the printing for quality control. And then you can see that the yield stress and the elastic modulus are directly related to the maximum height of printing. So just to recall what is the yield stress, it's really the stress that will unset the flow. So it's the stress that will enable the mixture to start flowing. So, and then to put it a bit in relation with other type of stress or mechanical strength, you can see that, the printable fresh mortar, they are, they are a little bit, it can be, if you take a normal standard fresh concrete, you can have, your printable material can be even stiffer, okay? So you see also that, there's been, at the moment, the boundaries of acceptable property are large, so it depends on what you print. and how you print it. And then you see that it's also, stiffer than fresh grout, because we have less water. So it gives you an indication of where we stand. And then in the lab, you can measure the dynamic yield stress with the flow table. So it's a very common ASTM test. You can also do the slump test. In my lab, we like to do the direct shear test that is also having a ASTM standard. And then for those who want very precise control of the rheology, you can do rheology test. I think the challenge there is very often it's easier to do rheology tests only on the paste. To do system that allows some sand, then, there are different type of rheometer, but I think it's already good to test your paste alone. Then in terms of the inline test, we've seen one test that arose a few years ago is the slug test, and it's quite interesting. So they measure the formation of the slug at the outlet of the nozzle, and we can do image analysis, and depending on the dimension of the slug, then there's a relationship between the dimension and the yield stress. So, we recommend you reading that article. I think that can be very indicative for doing quality control in the process during the printing. And then there's another test that is with the sissometer, and then you need to print an element, and then you do a destructive test. And that's also a good practice to do it. And then if you really measure your yield stress, then you see that it has a direct impact on, the quality control, so the height of your layers and how many layers you can print. Because when we look at it, what will enable the flow, it's really related to your aggregate particle distribution. So also what is the relationship? And then I think there's future work to be doing there to really try to optimize your mix design by optimization of the packing. And then the shape of the particle, if you have only round or more like angular aggregate, will also impact your packing. And then you can see how your viscosity evolve over time. And then you can do a matrix of particle packing. And then what are your rheological properties? So I think that's a very important step as well. And then we also need to think that there's also this elastic modulus and the compressive strength evolution. So your requirement will depend on how many layers you want to print, basically. And then, there's usually, an evolution of this that goes with the number of layers. And then we can see it presented in another way, but basically the higher will be your element, the higher will be your required elastic modulus. And then you can see, and then the aim of this chapter is really also to gather the literature, so you can see, also you can go back to other articles that explain into more details, but here you will see how your yield stress and your density are really connected to the layer stability and geometry. And then you can see also some specific requirement for your elastic modulus that varies with your density, basically. So I think, and your yield stress as well. So you see how important it is to know these values. But I think the good point is you can also estimate your yield stress with simple tests, like the slump test or the flow table. So that's, that's good to know. And then, to conclude, I think we see that the material selection will have an impact on the printing layers and the final structure. The yield stress is really the critical parameter to characterize in the development process. And then you can do it in the laboratory and during the printing. And you see that the total height will vary with your mixture density, yield stress, and elastic modulus. So, I will be willing to discuss that with you now. And also we have a committee meeting on Tuesday at 10 to 12. So if you want to discuss with us to see the state of the report, or if you're willing to contribute, we're looking also for more members to join our group. So everyone is welcome. So Then I will be able to take your question now.
Okay, sorry, I have too many questions today.
Yeah.
So if I'm going to redo my sidewalk, or just a driveway, I will get a contract. The contract will get ready mix to do it. If he takes cement, sand, aggregates to the job site, mixing on site, I would be scared, right? I think, you may think the same way. So right now, if you check, social media, read the newspaper, TV news, there are some people, they do 3D printing, mix on job site.
Yeah.
Batch mixing on job site. So I want you, so in your chapter, it seems, I don't think you addressed it yet. So my question to you is, between the job site mix versus the pre-mix, 3D printing mortar concrete, what's your comments on that? Thank you.
Okay. Well, I think if you want to really control well all the operation, it's better to do it in the setting of prefabrication. So, in a factory or in a place or in a producer site where you can really do, I think it's better for prefabricated, but it's true that we see a lot. So I think also what we start seeing is some manufacturing are preparing pre-packed, bags. So you have your dry and mixture in it. So you just have to add the water. So some manufacturers are trying to make it very easy. So you just have to bring bags on site and then mix it as a regular concrete. So I think that this will still go on. I don't think that will stop. I think we need to, maybe it's too early to assess what is the quality or the durability of a structure that is done in a prefabricated setting compared to mixed on site. I think that will be interesting to follow up over time. But it's a good question that you have. But I think it's also something we need to follow over time. Yeah. The behavior change over time. So, before the concrete harden, before the cement harden, then we have a more fluid behavior, but then there's an evolution of the behavior and then it becomes a solid. So I think that it's also the nature of cement that does it like that. It's first more fluid and then it's, a thixotropic material, so the more you will mix it, the more fluid it will be, but then once the hydration starts and if you start adding accelerator in it, then you will fasten the solidification of it. So I think we need to take into account both. But I think it's good to record the time from which it's a fluid and then when it becomes a solid. And it varies with your mix design and your process. But it's also very important for the pumping because, and your cleaning, because, you want to be able to clean everything before it's hardened. So it's very important in the process.